Now we're going to discuss about multiplication of two 8-bit numbers using 8085. So multiplication of two 8-bit numbers in 8085. So multiplication, let's see like simple multiplication, then I'll write a program based on that. Let's have 0 cross 3, 0 2, secondly 0 6. So repeated addition is called multiplication. That we have to be very clear. Now let's have this. Let me explain. Now 0 3 is your multiplicand, this is your 0 2 is your multiplier. So 3 cross 2 is you're going to add 3 2 times. So how it will happen is here is 0 3 plus 0 0, it is 0 3. Again it will be added with 0 3 to form 0 6. This is how repeated addition is happening in case of 8085. Now let's see how this repeated addition happens. So already we have seen addition of two 8-bit numbers. The same way here also it is going to proceed. Now let me take immediate addressing. So I move MVI A comma, or let me have MVI B comma 0 3. And MVI A comma 0 0. MVI A comma 0 0. That means what? I say B is equal to 0 3 and A is equal to 0 0. So B is a register, A is an accumulator, that is also a register, 8-bit register. Now repeated addition. So when I say repeated addition, let me start with addition, add B. So add B, when I say, it is called 3 plus 0, B plus A, that is nothing but 0 3 plus 0 0, which is nothing but 0 3. Whenever addition is over, it has to check for a carry flag, as you have seen in addition. So let's see, check for carry, jump no carry. So when there is no carry, when there is a carry, what happens? So whenever you have to check for a carry, you always have to initialize a carry. So in the top, let me do that initialization, MVIC comma 0 0. So carry register is initialized where C is equal to 0 0. That is your carry register. Now check for carry. If there is no carry, any carry, 0 3 plus 0 0 is 0 3. So first time addition is over, there is no carry. Jump on no carry. So I cannot store the result because it is not addition, it is repeated addition. It is a multiplication program. So I have to again add. So what I'm supposed to do? Now I have to initialize my multiplier, which is 0 because 2 times I have to add. So MVI D comma 0 2. MVI 0 comma 2 because 3 cross 2 I am doing. So this is my multiplier. Now if there is no carry, what it has to do is it has to go to loop L1. So what does the loop L1 do? One time addition is over, it has to decrease the multiplier. So I say decrement D. This D becomes 0 1. So one time the multiplication is over. So one time the addition is over because it has to do 2 times. So first time it's over. So decrement D. So one more time it has to do because now D is not equal to 0. D2 becomes 1 because you've decremented. Only if it is equal to 0, the operation is over. Now it is not equal to 0. One more time you have to do. So you are decrementing D 1. So you are checking for a 0 flag, whether D is 0 or not. Jump on no 0. If it is not equal to 0, go to some loop. Now D is not equal to 0. So it has to go to some loop because one more time addition has to happen. So what is that loop? What is that loop is here, add B. So this is your loop, L2. If it is not equal to 0, again add. So add B means B plus A. Already A is what? Already now after adding, answer is 0 3, which is stored in accumulator. So this is an accumulator. Again when you give add B, it is B plus A. So already in A 3 is there. B is already 3 we have initially. So 3 plus 3 it becomes 6. Now accumulator will become 6. Now again it will ask whether there is a carry. There is no carry. So here there is no carry flag set because it's small number we have taken. When we take bigger numbers, when we multiply, definitely we'll get a carry. So if there is no carry, where it has to go? Again it has to decrement. Already D was 0, 1. Now D becomes 0, 0. So D from 1, you have decremented again. It has become 0. Decrementing D. So now checking for 0 flag. Now actually D is 0. So when D is 0, immediately it has to stop the operation. That is 2 times it has added. Now what you have to do, you have to, when D is 0, store the accumulator content. What is accumulator content? 6. Store the accumulator content in some location 8200. Now if there is any carry, you can have that carry. Otherwise, what do you do? Regular process. There is no carry, but still we have a carry register. So what we do? Move the carry register to accumulator. Now store the carry in 8201. There is no carry. Carry is 0. So now the answer is in 8200 you have your 06, and in 8201 you have your 00, which is your carry. So this is your answer. This is your carry. So this is how the multiplication in 8085 it proceeds. Thank you all.